Hi, I'm Taylor.
I'm Izzy.
And I'm Mark.
And I'm Trent. And we chose San Diego State to do our project because it's got lots of shapes. And Izzy's ignorant and made us come here. Let's get it.
Taylor, and I'm going to tell you about regular polygons. A regular polygon is a shape that is equilateral and equiangular. An example of that would be this square in the concrete. It's regular because all four sides are equal and all four angles are equal as well. So that's another example of a regular polygon because it's an octagon with all equal sides and each angle measures 135 degrees. So this was the student union, and now we're headed to the library.
Hi, I'm Mark. I'm here at the library, and I'll also be talking about Chapter 16, the relationship between polygons. Right here we have a trapezoid, a standard trapezoid, which is defined as a polygon with two bases that are parallel. Next to it is a rectangle, which is a special trapezoid. It has two sets of parallel sides, and in the middle is a square, which also has two sets of parallel sides that are also congruent. A rectangle is a special trapezoid, and a square is a special rectangle as well as a special trapezoid. A square is always a rectangle and always a trapezoid, and a trapezoid is sometimes a rectangle and sometimes a square. A rectangle is sometimes a square and always a trapezoid. Next we will be walking to Hepner Hall to look at the difference between prisms and pyramids.
Hi, I'm Izzy, and we're outside Hepner Hall looking at the Hardy Memorial Tower, talking about Chapter 17, the difference between prisms and pyramids. The majority of this tower is a prism, and that means that it has two bases that are equal and congruent. In this case, they're going to be a square. And then they have their lateral edges on the side. And if you want it to be a right prism, that means that the lateral edges on the side are perpendicular, so it creates a 90-degree angle with the base. So the top of Hardy Tower is actually a pyramid, and this means that it has one base and then one apex at the top, where all the lateral edges combine to. If it wants to be a right pyramid, then that means that all the lateral edges have to be congruent. Now we're headed to the turtle pond to talk about rotational symmetry and reflective symmetry.
Alright, so we out here at this turtle pond, and we found a turtle. Turns out, turtles actually have reflective symmetry, because if we were to draw a line straight down the center of the turtle, technically we could fold it over and it would be the same. Yeah! Alright, so we also have to talk about rotational symmetry. If we look here at this water drain cap thing, we can see it's in the shape of a rectangle, and if we rotate that 180 degrees, it will still be a rectangle that has the same dimensions. Some shapes also have lots of different rotational symmetries that we can mess with. For example, a circle, no matter how many times you rotate it or how many degrees you rotate it, it will always still be the same shape, size, and dimension of the original starting position. So, turns out we found some pyramids on the top of this elevator thing. and I'm going to talk to you about the surface area of pyramids if you wanted to paint it. Cut it. So, let's say we wanted to paint the pyramid. First, we got to find the surface area of the whole pyramid, and by doing that, all we got to do is find the area of each individual polygon on the pyramid, which are all triangles. The area of a triangle is 1/2 base times the height. So all we gotta do is do 1/2 base times height, and then multiply that by 4, and we'll find the surface area of the whole pyramid. There's also a base. Even though we can't see the base, we can still really paint it if we wanted to. And the base is just a square. So all I gotta do for the base is base times width, or length times width. Same thing. And then you can paint that if you really want to, even though you can't see that. So basically, all the surface area is just the sum of all 4 triangles on the pyramid and the sum of the area of the base. And that is surface area for a pyramid.
Oh look, this trash can is also a cylinder.
They're pretty ugly and gray. I think we should paint them. How much paint would we need?
To find the surface area of a cylinder, we have to find the sum of the area of 2 bases as well as the lateral face. So the sum of 2 bases is pi r squared, and there's 2 bases, so you multiply by 2. So 2 pi r squared plus a lateral face that is a rectangle when you fold it out. The length of the rectangle is equal to the circumference, which is 2 pi r, multiplied by the height. So 2 pi r h plus 2 pi r squared.
Let's go buy paint. Emergency! Emergency!
If this prism was painted orange, Izzy would have been able to find the emergency button. In order to paint this prism, we would have to find the area of each face. For the rectangular faces, we would just do base times height, multiply that by 4, and then for the square bases on the top, on the bottom, and the bottom, we would do the length times width as well, and you'd multiply it by 2, and you'd add them together.
So, you always have to remember, when dealing with surface area, to use the right units, which would be units squared. If we were painting in inches, it would be inches squared. If it was centimeters, it would be centimeters squared.
This concludes our math trail of San Diego State. I talked about chapter 16 and the definition of a regular polygon, and Mark talked about the relationship between different polygons such as trapezoids, rectangles, and squares.
And I talked about chapter 17, which was the difference between prisms and pyramids. And I also talked about what makes them a right prism or a right pyramid.
I talked about chapter 18, we looked at turtles and how they have reflectional symmetry, and then we also talked about a square and a rectangle and how they have rotational symmetry.
Finally, we all talked about chapter 25. We talked about the surface area of pyramids, cylinders, and prisms.